First part of this question says express 3 over 2x minus 1, x plus 1 in partial fractions. They're both linear factors in the denominator. So we can straight away write 3 over 2x minus 1, x plus 1, is the same as a over 2x minus 1 plus b over x plus 1. So that gives us that 3 would be going clearer fractions. So we're multiplying everything by this denominator. So when we multiply the a, the 2x minus 1s will cancel, leaving us with ax plus 1. When we multiply this term over here, the x plus 1s cancel, leaving us with this. And then let's just take x equal to -1. If we do that, we get 3 equals the first term with the a, that's going to disappear. X equals -1, substitute in there, we're going to get -3b, and that tells me that b is -1. And if I take x equals 1/2, that means that this one will disappear, and we'll get 3 over 2a, 1.5 a's, which means that a is equal to 2. And so we get 2 over 2x minus 1, take away 1 over x plus 1. So, scientists mixed two chemicals. So it's two chemicals, A and B, and mixed oxygen is produced. Scientists mix these two chemicals and measure the total volume of oxygen produced over a period of time. The total volume of oxygen produced, V cubic meters, T hours after the chemicals were mixed, is modeled by this differential equation. Note, with the V's moved over to the other side, it's very much like what we just worked with, where K is a constant. So V is greater than or equal to 0, T is greater than or equal to K, where K is a constant. Given that exactly 2 hours after the chemicals were mixed, the total volume is 3 cubic meters. Solve the differential equation to show this. So this is a target expression that we've got. So, well, let's have a look at the equation. So we've got 3v over 2t take away 1, t plus 1. Let's separate. So we get 1 over v dv is equal to 3 over 2t take away 1, t plus 1 dt, and separate, and then we integrate, and then that's going to give me ln v. Don't need to worry about the modulus because it says it's greater than or equal to 0, and that is going to be equal to the integral of 2 over 2t take away 1 over t plus 1 dt. And so my ln v is equal to, so if we integrate this, it's going to be ln 2t take away 1, divide by the differential of the inside function, which is 2, and that will cancel with the 2 on top. So it's going to be ln 2t take away 1. So what we're doing there was ln 2t take away 1 divided by 2, and that cancels with the 2 that was already there. And then the next one is going to be ln t plus 1. Again, I don't need to worry about the modulus. But what I like to do in this situation is write my constant as ln a instead of plus c. Since we've got all logs here, that is going to be ln v using log laws. So we've got the subtraction log law, which will give me 2t take away 1 over t plus 1. And the addition log law, which will move the a inside here. And since we have that, we can ignore the logs. And then we just get a 2t take 1 over t plus 1. And then we can use the information we were given in the question. So v is 3 when t was 2. So that is going to be a. T is 2, we've got 4 take away 1, 3 over 3, and that gives me that a is equal to 3. Substitute that back to here, and we get the expression that we had, 3 2t take away 1 over t plus 1. The scientists noticed that there was a time delay between the chemicals being mixed and oxygen being produced, and there was a limit to the total volume of oxygen produced. Deduce from the model the time delay and the limit. So for V is the volume of oxygen. We need it to be positive, and it won't be positive until T is 0.5. So for part 1, we're going to get half an hour. Now for part 2, there's going to be a limit, and the limit is when T tends to infinity. So we can write V as being 6t take away 3 over t plus 1. When we look at the limit situation, we can ignore the 3 and the 1. We're just looking at t tending to infinity, and then the t's will cancel. So we can see that it's going to be 6 cubic meters.